Hello everyone, let's see the first problem from CodeChef Starters 80, Division 4. Okay, that says just one more episode. So chef has to attend an exam that starts in X minutes, but of course, watching shows takes priority. Okay, every episode of the show that chef is watching is 24 minutes long. If he starts watching a new episode now, will he finish watching it strictly before the exam starts? Okay, so the question is something like, will be given an X, which means after how many minutes his exam will start, and each episode is 24 minutes long. So we have to tell that if he will be able to finish his show or not before the exam. So let's say X is 23. Okay, his exam starts in 23 minutes, but his show is 24 minutes long, right? So until his show finishes, his exam will start, right? Let's say X is 30. Okay, his exam will start in 30 minutes, but his show is 24 minutes long, right? So he'll finish it in 24 minutes, and after 6 minutes he can start his exam, right? Let's say his exam starts at 24 minutes, his show is also 24 minutes long, right? So right when his show ends, at that very moment his exam is starting, right? He can't attend the exam, right? Like, if his show ends at 24th minute, to attend his exam the exam has to start at the very next minute, right? That is from 25th minute. But his show is ending at this moment, and right at this moment his um, exam is starting, so it's not possible for him to finish the show, right? So that's the situation. Very simple problem. We can clearly see in the test cases that 30 minutes he can start, he can finish. 23 he can't, right? 60 minutes he has a lot of time, he can finish. In 24 minutes, if his exam is in 24 minutes, he can't start, right? So no. So just a condition. Okay, if the given time is greater than 24, then only he can finish the show, right? Otherwise he can't. Okay, now let's see the second problem, single use attack. So this is a video game, some video game is going on. So there is a boss who has a health of H. Okay, and our chef is going to perform some attacks. Each of his attacks has a power of X. Okay, but he has a special attack which has a power of Y. Okay, he can use it only one time. So we have to tell that how many minimum number of attacks he has to perform in order to make his health lesser than equal to or lesser than 0. That is deplete his health totally, right? So if he performs an attack of X, his health becomes H minus X, right? Pretty simple. If he performs his special attacks, his health becomes H minus Y, right? That power is subtracted from the health. Okay, now what are we going to do if we have the health H? Okay, as per my habit, what I am going to do, I am directly going to use my special attack, that is H minus Y. Fine. Now if we perform this, we perform one attack, right? So our number of attacks increases by 1. Okay, fine. Now whatever we will be left with, whatever the health is left, let's say the health is left is say H dash. Okay, anything you can call. In this one we will try to make the rest of the attacks. Okay, that is H. So how many attacks can we make? We can make H by X, right? Not H by X, we can make ceiling of H by X. Why ceiling? Because let's say the health left is, let's say, 5. Okay, and our this normal attack power is, let's say, 2. So how many can we apply? How many moves can we apply? We can apply 2 here, right? That is 2. Okay, but still one health would be left, right? Isn't it? 1 2 3 4 5. This is our X, this is our X. We depleted these power, right? These health. Now this one would be left, right? So we will make one more attack and deplete this one as well, right? That's nothing but ceiling of 5 by 2, isn't it? Ceiling of 5 by 2. So this is the solution. So initially we initialize our answer with 1, because we are always right at the very beginning we are applying our special move, right? So we take one move, isn't it? Then we deplete that special move power from our H. Okay, now whatever is left on that thing, we try to apply the normal attacks, right? If anything is left, like if the boss is alive, that is H is greater than 0, if he has any health left, then only we apply that power. Okay, and that thing is added to our answer, right? We saw that in the whiteboarding just now. Otherwise, if nothing is left, so that's just going to be our answer 1. Right at the first attack, the boss died, right? So we return answer. Let's see the third problem, running comparison. Alice and Bob are running, and They decided to compare how much they ran on different days. They ran for n days. On the ith day, Alice ran A of I meters and Bob ran B of I meters. Now, Alice is unhappy if Bob ran strictly more than twice her distance and happy otherwise. That is, if Bob ran twice than what Alice ran, then Alice is unhappy. Alice is unhappy. Let's say unhappy UH. And similarly, if Alice ran strictly more than twice of what Bob ran, then Bob is unhappy. Okay. And in this case, if Alice is unhappy, Bob is happy. And in this case, Alice is happy because Alice defeated Bob, right? So let's see the example. Alice ran 200 meters and Bob ran 500 meters. Alice would be unhappy, but Bob would be happy, right? Because Bob defeated her. Similarly, here Alice has defeated Bob, so Alice is happy, but Bob is unhappy. Alice ran 300 meters and Bob ran 500 meters. Both Alice and Bob would be happy because no one defeated no one, right? On how many days out of the n days both Alice and Bob were happy? We have to find that. Now this is the solution that I have written. We of course take the input n and we create two separate arrays for Alice and Bob, and in each of them we record their running distances for each ith day, right? Then we take a count variable. Okay, this is going to count how many days both are happy. Now at each step, at each index, we check for both of them. We check the conditions. We create this variable, boolean variable. A happy means Alice happy. Is distance of Alice is strictly greater than twice the distance of Bob. Okay, let's say it is true. Okay, let's say Alice won in this situation, so definitely this one will be false, right? Now what are we going to do? We are going to do a XOR operation between A happy and B happy. Okay, so if A happy is true and B happy is false, the XOR is going to give a true, right? Therefore don't increase the count. One has won, one has been defeated, right? Both of them are not happy, so don't increase. Let's say Bob has won. For Bob this condition is true. Okay, this condition is true, so definitely for Alice this would remain as false. So if we do a XOR between true and false, we will get a true, because we know that for same values, that is say 1 1, XOR of 1 1 and XOR of 0 0 is going to give us a what? It's going to give us a false, right? False or say 0. Okay, but if the values are different, 1 0 or XOR of 0 and 1, we are going to get true or 1. That means happy, sad, sad, happy, unhappy, right? So if one of them is unhappy and another is happy, so we will get a true, right, out of this expression. So don't increase the count. Now let's take this example. See this, 300 and 500, right? Alice ran 300, Bob ran 500 at a particular day. So what will happen? 300 is not greater than twice of 500, right? 2 into 500, right? So in that case, Alice remains unhappy and Bob remains happy, isn't it? And in this case, 500 is not greater than twice of 300. So Alice becomes happy in this case and Bob remains unhappy, right? So that's why I have used this XOR operation, right? We are not, if Alice remains unhappy, we are not explicitly again changing the Bob happy value to happy, right? To true, right? So that's why we have used the XOR operation. If both of them are unhappy, means both of them are happy, right? Why is Alice unhappy? Because Bob has won, right? At the same time, Bob is also unhappy because Alice has won. So this kind of contradicts, right? So both of them are unhappy. That means none of them has won. If none of them has won, then none of them is unhappy, we can say, right? That, say I have a friend who couldn't win, right? So I'm happy for that, and I also couldn't win, that's why my friend is also happy. So we can say that. So that's why a XOR operation. It might sound a bit confusing, but try to think about it, it would make some sense, right? So at the end we print the count. Okay, so this is the third problem. You can solve it in many other ways. This one just popped up in my mind at that moment and I just did it. Okay, now let's see the fourth problem. Equal elements. You are given an array A of size n. In one operation you can do the following. select indices I and j where I is not equal to j and set both of them equal. Okay, find the minimum number of operations required to make all the array elements equal. So let's say we have this array 1 2 3 and 4. Okay, we want to make all these elements equal to a number. What can we do? It's our choice. We can turn this 1 to 2, this 3 to 2, this 4 to 2. They become equal in 3 steps. Okay, let's say we have, or we can otherwise do it. If it's 1 2 3 4, we can turn all of them to ones. Still 3 steps, right? 3 moves are required. But now let's say we have this 2 2 1 and 3. Now we can do many things, right? We can turn all of them to ones, right? We can turn all of them to twos, and we can turn all of them to threes. Now which would be wiser to do? We have 2 2 1 3, right? Already these two elements are 2, so wouldn't it be wise to make the rest of the elements 2, right? Because that's taking us lesser number of moves. Because for our help already two elements are given to be equal, so let's just change the rest of the elements to this particular element, right? This would take lesser number of steps, because in this we took 3 steps, 3 moves. In this one also we took 3 moves, right? So we will turn these 1 and 3 to 2s. We took two moves, isn't it? Let's say we have this array 2 2 2 1 3. If we turn all of them to ones, how many moves will we take? We will take 4 moves. But already 3 elements are equal out of 5. So let's just change these two elements to 2, right? That would be better. So what are we going to do? We are going to record the frequencies of our elements in our given sequence or the array. Okay, if if the frequency of all the elements is same, we can choose any one of them and change all of them to that particular element. Otherwise, if there is an element whose, say we have 3 3 3 1 2, if we have an element whose frequency is largest, okay, we will pick that one and we will change the rest of that elements to this particular element. Okay, so what are we actually doing? We are checking which element has the maximum frequency. Okay, so what would be our answer? If the length of our array is m, then our answer would be n minus max frequency, isn't it? Let's check once more. 2 2 1 3. We have these two, the frequency is 2. We change the rest of the two elements, right? That is 4 minus 2, that is 2, right? In this one our array elements is 3 3 3 1 2. Frequency of 3 is 3. The size is 5. 5 minus 3, right? We took 2 moves, 1 and 2. So that's what we are going to do. So this is the solution. We take the count, then we create the array to record the values, and we create a hash map to count the frequencies. And at each step we update the frequency of each element in our map. Then we get the maximum frequency using this collections.max from our map.values, right? Because our frequency, our map is in the form of element to frequency, right? So values are our frequencies. So whatever is the max, we subtract it from our length of the sequence. So that gives us the minimum number of moves required to make all the elements equal, right? Now let's see the fifth problem. Now I will tell in shortcut what the fifth problem actually is. We will be given n and we will have to generate a permutation of the numbers from 1 to n. Okay, let's say this is our permutation. Let's say 1 2 3 4 5 6. Okay, let's say n given is 6 for now. Now we have to generate this permutation in such a way that if we consider these indices, this would be one index, let's say sequence. Okay, this index would be 1, this would be 2, this would be 3 4 5 and 6. We have to generate them in such a way that if we take the sum, prefix sum of these two elements, this should not be divisible by this index. What is the sum? 3. 3 is not divisible by 2. Okay, fine. Now if we take these three, 1 2 and 3, what is the sum? It's 6, right? Now is this sum, prefix sum, divisible by 3? Yes, it is divisible, right? So this can't be our permutation. So we have to generate a permutation in such a way that from 1 to prefix sum from 1 to that particular index, whatever the sum is, it should not be divisible by the index value. Okay, so that's what our question is. There is no such fancy thing in this question, just I did just some hit and trial. Okay, now if this is our sequence, if we reverse every alternate numbers, right? Let's say 1 2, if we do 2 1 4 3 6 5 like this, we get our desired result. Okay, 1 2 3 4, 5 and 6. Okay, this is 3. 3 is not divisible by 2. Okay, this is 4 plus 1, 5, 7. 7 is not divisible by 3. This is 10. 10 is not divisible by 4. This is 15, not divisible by what? Not 15, sorry, 16, not divisible by 5. And finally, this is 16 plus 5, 21, not divisible by 6. So this is going to be our answer. There can be multiple answers, right? We have been said maybe if multiple exist, print any one of them. So this one is I have done this one. Okay, now there is an edge case. If the given n is odd, okay, then our answer is going to be -1. Why? Let's see. We know that the sum of 1 to n natural numbers is given by n into n plus 1 by 2, right? Now if our n is even, let's take an example, let's say 4, then what is the sum up to n numbers going to be? The sum up to n numbers mean ultimately, let's say if we have 1 2 3 4, this is the final prefix sum, right? From 1 to n. So 4 into 5 by 2, that is 10. Now is 10 divisible by n? 10 is not divisible by n. But if our n is odd, that our prefix sum would be from 1 to n would be 5 into 6 by 2, which is nothing but 30 by 2, 15. Now 15 is divisible by n, isn't it? So that means we don't know what's happening till now, but if we have an odd number, if our n is odd, the prefix sum till here is going to be divisible by the index number. So that's why in such a case we can't form a permutation, we have to return -1. Okay, now let us quickly see the code. Right at the beginning, if our n is odd, then print -1 and terminate it. Okay, terminate this test case, go to the another. Otherwise we print our sequence. How? We start from 2, we print 2, then space 2 minus 1, 1, we print 1. Then we take a jump of 2, 2 becomes 4, we print 4. Then we print 4 minus 1, 3. Then from 4 we go to 6, then we print 6 minus 1, that is 5. So like this we print our permutation. Okay, and at the end we print a new line, right? So this is our solution. Fine. Now let's see the sixth problem. A permutation subsequence of length m is a subsequence that represents a permutation of length m. Okay. Shefina asks Chef to find the count of permutation subsequences in array A. The count can be very large. Output it in modulo this. Okay. A subsequence of an array is obtained by deleting some, possibly 0. Okay, that's pretty clear. We know that. A permutation of length m is an array of length m in which every element from 1 to m occurs exactly once. Okay. What does this mean? Let's say our m is something, say 5. Okay, we have to create a permutation something like this: 2 3 4 and 5. This is a permutation, this and this is a permutation, then this and this is a permutation, this and this is a permutation, and this is a permutation. Now we have been given an array, okay, which has the frequency of the numbers from 1 to m. Let's see this example. Say this is n. Okay, so this is our array. What does this mean? 1 has occurred 1 time, 2 has occurred 2 times, 3 and 4 1 time. Now we have to form permutations from this array. How? Let's see. So we have 1 2 3 2 4, that is 1 2 and 2 3 and 4, right? So this 1 and 2 and this 1 and 2 can form two permutations. Initially 1 itself is a permutation, right? Then 1 and 2, then again 1 and 2, right? Now if we move further, this one will create a permutation, right? 1 2 and 3. Then this one will create another 1 2 and 3, and then both of them will form one more, right? That is 1 2 3 4 2 times, isn't it? Now the thing here is actually a bit different. Just for the sake of how we are going to create permutations, I have showed this one, but we have to form permutation in the order of our given array: 1 2 3 2 4, right? So we have to form permutation like this: this one, then this 1 and 2, then this 1 2 and 3. Okay, then this 1 2 3 and 4, we can't take this 2 because it has already occurred once. Okay, then this 1 and 2, then this 1 3 2 4. Okay, also this 1 3 and 2. Whatever permutation we choose, we have to make sure that if we choose say 1 2 3, we have everything in that range, right? 1 2 and 3. We can't choose something like 1 2 and 4. 3 is missing, right? We can't do that. We have to choose in such a way. So if you look at this example, let's try to form our permutations. We have 1. Okay, we have 1 and 2, then we have this 1 and 2. Okay, then what? We have 1 2 and 3, 1 2 and 3. Then if we skip this 2, we have 1 2 3 and 4. Okay, then let's skip this 2, we have 1 3 2 4. We have 1 3 2 first, right? Then we have 1 3 2 4, 3 2 4, right? How many? 1 2 3 4 5 6 7. Now here if we see, here we have one permutation. Here we took how many permutations? This one and this one, two permutations. Then here we came from this way we created one, this way we created another, right? That is two permutations. Then we again came from this way, one permutation, from this way another permutation, that is two. So how many? 7 in total, isn't it? Now let's see the other example. 1 3 5 8 9 8. 1 3 5 8 9 8. 1 2 3 5 8 8 9. 2 doesn't occur in our array, right? We will have this permutation. Okay, one permutation here, but we don't have a 2. We don't have a 2. If we don't have a 2, we can't move to 3. We Whichever permutation we create, we have to include all the numbers in between till within this range 1 and 3. If it's 2, we have to include 2. If it's 5, we have to include 1 2 3 and 4 and 5, right? So this way we are going to form our permutation. So in any case a number doesn't exist, then we can't move any further, we can't create any permutation. Okay, if by any chance a number is missing, okay, if its frequency is 0. Okay, say we had a 2 in this case, say we had a 2. Okay, then how would we form the permutation? This one, then this 1 and 2, then this 1 2 and 3. Then we want to go to 4, but we don't have a 4. Okay, this will be our final permutations. So we had a 4, then we will include 1 2 3 and 4, then 1 2 3 4 5, then we need 6 and 7, right? So that's how we are going to create our permutations. So what is our approach going to be? First of all, we will record that array, right? Whatever we are given, 1 2 3 2 4, and we will use a hash map to record their frequencies. Okay, then we will loop from 1 to n. Okay, 1 to n, and we will create the permutations. How? By using their frequencies. Now if we observe, this is our answer, right? How did we do it? By summing these values, right? Now how did we get these values? See, this is 1, its frequency is 1. How many permutations is it going to create with these two? That is, it will be this frequency into the previous frequency, right? So this becomes 2. Now what about this? Its frequency is 1, right? How many permutations is it going to create? It's going to create this frequency into the previous number of permutations till 2. What about this? Its frequency is 1, right? Permutations till here is 2. This will create permutations till previous number into current frequency. That's how we are getting this, right? And at the end we add all of them to get the total number of permutations. Now let's get back to our example. So what is the frequency of 1? The frequency of 1 is 1. Okay, so permutations till 1 is 1. Okay, fine. So we are going to add this to our answer, right? Answer is 1 for now. Then we go to 2. How many permutations of 2? Sorry, what is the frequency of 2? It's 2, right? So we will multiply this frequency to the previous number of permutations. What was that? It was 1, right? So we will have to keep the number of permutations till previous number recorded in some variable. So let's say this is previous. So previous into our current frequency, that is 2. Okay, add this 2 into our answer. Okay, fine. Now previous number of permutations becomes 2. Now let's go to 3. Go to 3. What is the frequency? It's 1. How many permutations can it make? Current frequency into permutations till previous number, that is 2. 1 into 2, that is 2. Add this into the answer. Fine. Now let's go to 4. What is the frequency? 1. What is the number of permutations till previous number? It's 2. So it's going to make 2 into 1 permutations till 4. So add this, right? So this is going to be our answer, that is 7, right? It's clear, right? If we take this once more, I'm showing 1 2 2 3 and 4. 1 here, this creates a frequency into previous permutations, that is 2. This one creates this and this frequency into previous permutations, that is 2. This one creates this and this frequency into previous permutation, that is 2. Simple thing. Okay, now let's see the code. We declare a mod variable, right? Because we have been given to return our answer modulo this, right? Now we create a hash map to record the frequencies. Fine. Now we declare two variables, product and answer. This is nothing but the previous, in the contest I declared as product, no problem. Both of them is long to just to avoid any error. Okay, so we start iterating from 1 till n equals to n. If the number in the range 1 to n, if the number is not present in the map, that means it was not given in the array, right? So we won't be able to create any further permutations, because our permutation needs to have all the numbers in that range 1 2 3 4 5, not 1 2 4 5 like that. We can't miss any of them. So in any case we miss, that means we can't move further. We simply break out whatever answer we have calculated, we will return it. Otherwise we will compute the current number of permutations for current digit, right? That is previous number. We rephrase them to previous. Okay, previous into current frequency, right? We saw that. Let's say this is 3, let's say this is 2 2. Till here permutations was 2, here frequency is 1. Current frequency into previous number of permutations, right? This gives us 2. Okay, this is the current permutation, this one. Add this to our answer. Okay, we added this to our answer. In both of these steps we mod them, right? In any case they become very big, we mod them and bring them to a smaller value. Okay, and this current number of permutations becomes the previous now for our next step, right? Because we go to 4 next, right? So this current would become the previous for this 4, right? And at the end we finally return our answer. So this is our solution. And it's a bit confusing, like I also faced a bit of difficulty in this one, right? Also it's a 1500 dated problem. So yeah, this is all about this video. So if you have any kind of doubt, you can put that up in the comment section, and like and share this video. Subscribe to my channel. I will see you in the next video. Bye bye.